Voyager sending back terrifying information to Earth. The Voyager 1, NASA's farthest traveled spacecraft, continues to be touring across uncovered areas of the cosmos nearly 50 years after its launch. Scientists are baffled by the frightening facts that this famous space probe system is sending back to Earth, cutting edge what appears to be a malfunction. Join us as we discuss the peculiar records that the Voyager has been transmitting back to Earth during its space exploration journey. Scientists have been involved in state-of-the-art greater about the nation's past since the Big Bang, and that's what inspired the release of the Voyager 1 and Voyager 2 among other space missions. Voyager 2 was genuinely the first spacecraft to launch, departing from the NASA Kennedy Space Center on August 21, 1977. On September 5 of that same year, Voyager 1 was launched 2 weeks later. However, how did they switch locations as twins? The weight of both probes is 720 pounds, approximately similar to a small car. Both of them were released during a window of unique planet alignments that caused a slingshot effect to launch the spacecraft from one planet to another. They've however needed to move at various speeds and on numerous trajectories. On December 15, 1977, Voyager 1 was capable of bypassing its identical twin, and since then it has been our go-to for numerous records in space-related riddles. The first spacecraft to accomplish this became this one when it started its Jovian imaging project in 1978. It was around 265 million kilometers from our planet and sent a huge amount of snapshots back to us. The Voyager 1 completed an awesome 108-hour stint beginning in January 1979, during which it captured 3,750 photographs of Jupiter's rotation to produce a time-lapse film displaying 10 of the planet's spins it passed through the Jovian moon system. In February 1979, and a month later, it discovered the little rings surrounding Jupiter. Voyager 1 also made a unique discovery when it found new moons named T-Andam. Accurate maneuvers were made to ensure that the spacecraft was ready for its flyby of Saturn and to prevent a potential collision with Titan, one of Saturn's moons. Voyager 1 also discovered 4 other moons during its orbit of Saturn, consisting of Mimas, Enceladus, Tus, and Dione. Scientists opted to halt the Voyager planetary task after the Saturn mission was completed and sent both Voyager 1 and Voyager 2 out of the doors of our solar system at a pace of 325 million m per year in January 1990. The new mission, officially known as the Voyager Interstellar Mission, got underway. One of the most well-known images depicting the solar system and the planets was taken by Voyager 1 on February 14, 1990. While it was 6 billion kilometers from the Sun, they noted it as the solar system's picture. There were 60 total pictures taken by Voyager 1, bringing the total number of pictures taken by the spacecraft to 670, despite the reality that Mercury and Mars cannot be visible in the photographs for various reasons. In the end, the spacecraft's cameras were shut off to conserve energy and memory before its trip to interstellar space. In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizon spacecraft. Prior to Voyager 1 passing by Pioneer 10 on February 17, 1998, the Pioneer 10 was the furthest spacecraft. Voyager 1 endured its journey for a further 14 years before it finally arrived in the interstellar environment on August 25, 2012, without any other space probes in sight to catch up with. However, NASA didn't publicly announce the accomplishment until 2013. In November 2018, each space probe officially left the solar system when Voyager 2 crossed the heliopause and entered the interstellar medium. Voyager 1 is thought to be 145 billion miles or 550 kilometers from Earth. It has persevered to provide us with vital records that no other space probe missions have been capable of revealing since it entered the undiscovered territory beyond our solar system. The spaceship has spent the majority of its 45-year experience in space in good health. However, in recent times, specialists have determined some abnormal anomalies in its performance. Voyager 1 is presently transmitting enigmatic signals back to Earth, giving the impression that it's uncertain about its location coordinates. There is a scary twist to the situation. Even though normally scientists have pre-programmed Voyager to enter safe mode or sound an alarm in the event that it becomes lost in space, up till this point it has not. Moreover, its antenna, which transmits data back to Earth, appears to be in exceptional working order. However, the data it has currently been transmitting is suspicious. The Interstellar Explorer is functioning, taking commands from Earth and carrying them out, as well as gathering and transmitting scientific data. However, readouts from the probe's articulation and control system do not accurately reflect what's taking place inside, according to NASA officials. What exactly is taking place on board then? Each spacecraft that is headed for interstellar space, including Voyager 1 and 2, has a special 12 inches diameter gold-plated disc that is loaded with audio and video messages as a backup in case an alien species discovers the ship. 35 Earth noises, 115 live images, 90 minutes of Western music and greetings from former U.S. President Jimmy Carter and former Undersecretary General Kurt Waldheim are only a few of the contents on the space DVD. Moreover, They're recorded in 55 distinctive languages, so if it was taken over by aliens they would possibly be attempting to decode the signals. The mind that the spaceship is presently under the direction of aliens has been quickly refused by scientists. Voyager ability to function depends heavily on the attitude and articulation control system. For starters, it constantly keeps its antenna aimed at Earth so that scientists can effectively acquire data. Moreover, it controls how the spaceship is oriented. Engineers keeping an eye on the situation now feel that the OX is functioning as it should, which simply adds to the enigma we already face. Moreover, none of the safety features designed to protect the spacecraft from danger have been activated, according to Susan Dodd, task supervisor for Voyager 1. A mystery like this is par for the course at this point in the Voyager venture. The spacecraft is about 45 years old, which is much older than what was envisaged in the undertaking plan. Dodd also recognizes that the spacecraft's engineering team will encounter some significant difficulties in resolving the issue with Voyager 1. The distance between us and the space probe present challenges largely because the spacecraft is about 145 billion miles away from Earth. This sizable distance introduces several complications that the group ought to navigate carefully. A rescue operation is nearly impossible given the current technological and logistical constraints. Voyager 1 is far beyond the reach of any spacecraft or repair project that we could feasibly send. The spacecraft's exceptional journey has taken it into the outermost areas of our solar system and beyond into interstellar space, where it continues to journey any farther from us. Everyday messages received from Earth at the speed of light take nearly 21 hours to reach Voyager 1's current location. Any command or training sent by the engineering crew requires a significant amount of time to be received by the spacecraft. This delay poses a tremendous challenge for real-time problem solving and troubleshooting. Moreover, once Voyager 1 approaches the command, any response or information it sends back to Earth will take another 21 hours to return. This means that two-way communication between Earth and the spacecraft takes an average of 2 days. This sort of delay makes it extraordinarily hard to implement quick fixes or iterative troubleshooting techniques that are critical when dealing with complicated technical problems. The engineering crew has to meticulously plan and execute every command, anticipating various eventualities and potential results. Unlike missions near Earth where engineers can swiftly send and receive instructions, the lengthy communication delay necessitates a more strategic and patient approach. Each preparation must be carefully crafted to address the recognized issues without causing more problems. Considering the prolonged time it will take to verify whether the command had the desired effect, the considerable communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This necessitates thorough testing and validation of commands on Earth before they're transmitted to Voyager 1. In addition to these logistical challenges, the spacecraft itself is over 4 decades old, having been launched in 1977. The technology on board, although advanced at the time, is now considered historical by contemporary standards. The engineering team must work with systems that were designed and built in the 70s, which adds another layer of complexity to the problem-solving process. The harsh environment of space also takes a toll on the spacecraft systems. Voyager 1 has been exposed to cosmic radiation, severe temperatures and micrometeoroids for over 45 years. These factors contribute to the wear and tear and degradation of its components, making it even more difficult to maintain and repair. Despite these hurdles, the engineering crew remains dedicated to resolving the issues. They're exploring various hypotheses about what might be causing the anomalies and testing potential solutions through simulations on Earth. This cautious, methodical approach is crucial given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The crew is also leveraging the redundancy built into Voyager 1 systems. Like many space missions, Voyager 1 was designed with backup systems to increase its resilience to failures. The engineering crew may be able to switch to these backup systems to restore normal operations if they determine that a specific point is malfunctioning. In summary, while the challenges of diagnosing and solving the issues with Voyager 1 are enormous, the engineering team is applying their expertise, experience and the spacecraft. Despite these challenges, engineers and scientists at NASA have been relentless in their efforts to maintain Voyager 1's functionality and continue its mission objectives. The spacecraft, now over 45 years old, has defied expectations and continues to provide invaluable data from the outer edges of our solar system and into interstellar space. Its endurance and resilience serve as a testament to human ingenuity and perseverance in exploring the cosmos. As Voyager 1 travels farther into the unknown, it remains a symbol of humanity's quest for knowledge and exploration beyond the confines of our home planet. The anomalies and challenges it faces only underscore the complexities and mysteries that lie in the vast expanse of space, driving scientists to push the boundaries of our understanding and inspiring future generations to continue the journey of exploration.